Have you ever wondered why spilt instant coffee powder turns into liquid after a time? Or why the soft white powder that doctors use to immobilize broken bones sets into a rigid solid when mixed with water? Some other compounds change both color and texture when mixed with ordinary water. Let us discover what makes all these compounds so interesting. A hydrate is a chemical compound that contains water as part of its crystal structure. The water in a hydrated compound is called the water of hydration or crystallization. The water of crystallization is a definite proportion of water present in the structure of a crystalline compound. The dot in the formula indicates that the two compounds are bound together. Water retains its properties as a separate and unique compound. Hydrated copper 2 sulfate crystals have a characteristic blue color. When these crystals are heated, the water of crystallization is driven off and a dry white powder is formed. This powder is called anhydrous copper 2 sulfate, CuSO4. When water is added to anhydrous copper 2 sulfate, the process is reversed, and the blue color appears as the copper 2 sulfate becomes hydrated. Most hydrates are stable at room temperature. However, some salts spontaneously lose their water of crystallization to the atmosphere. This is known as efflorescence. Efflorescent substances lose their water of crystallization fully or partially and crumble into a powder. Gypsum was left behind when inland seas dried up about 200 million years ago. In most cases, the gypsum layer had been buried by the accumulation of silt and dust. If the gypsum or calcium sulfate dihydrate is still near the surface, we can quarry it. If it is deeper, it must be mined. When powdered gypsum is heated to about 373 Kelvin, it loses water molecules. Now, calcium sulfate dihydrate changes to calcium sulfate hemihydrate. Hemi means half. This powdery white substance is called plaster of Paris. When you mix plaster of Paris with water, it turns back to gypsum again and becomes a hard, solid mass in about 30 minutes. As it sets, it becomes warm and expands very slightly. Plaster of Paris got its name because it used to be made from gypsum quarried from Montmartre in Paris. Plaster of Paris is used by doctors to immobilize broken bones until they heal. Plaster of Paris is used by law enforcement agencies to transfer tire tracks and footprints. plaster of Paris is also useful for making statues and other models. It is also used to make molds for sculpture and to make lifelike masks for performance. The credit for the invention of plaster of Paris in 1768 goes to Antoine Lavoisier, who was guillotined during the French Revolution. You must have seen that many optical and electronic items are packed with small pouches of silica gel. Have you wondered why? Silica gel is made from sodium silicate, Na2SiO3, which can become hydrated by absorbing moisture from the air. In this way, it serves as a drying agent and protects electronic devices against high humidity. Such anhydrous salts, which can absorb moisture from the air to become hydrated, are said to be hygroscopic. Hygroscopic compounds such as calcium oxide or quicklime are sometimes referred to as desiccants. If concentrated sulfuric acid is exposed to humid air, it increases in volume. Is concentrated sulfuric acid hygroscopic in nature? In 1999, frozen sulfuric acid was discovered on Jupiter's moon, Europa. The intense bright yellow areas represent regions of frozen sulfuric acid. Certain hygroscopic substances, such as anhydrous calcium chloride, CaCl2, not only absorb water vapor from the air, but themselves dissolve in that moisture, undergoing a change of state. Such substances are called deliquescent substances. The process is called deliquescence. In everyday life, you can observe deliquescence when you spill some instant coffee. This turns from a dry powder to a sticky liquid when exposed to air for a few hours.